review for the final exam. Question number 1, we are given a graph and we need to be able to read the graph to answer the following questions. The first question says, find f at -1. That means when x is -1 on the graph, what is the y value? So x is given to you. You're going to put your pencil at -1x and trace the graph. The graph is right here. You don't have to go anywhere. And then to read this y value, you go to the y-axis, and y here is 0. So the answer is 0. This is another way of writing a point. So a point -1, 0 could be written like that. The next one, it says when x is 3, what is the y value? So again, this is your x value. X is 3. You're looking for the corresponding y. To find the corresponding y, put your pencil at 3, then trace, then this is your graph, and then go to the y-axis to find the y value. The y value is 2. So when x is 3, y is 2, or f at 3 is 2. They're the same thing. It says x's, find the x's where f of x is y. So it says when y is -1, what is the corresponding x? So go to -1 on your graph, and then try to go to -1 on your graph, and then try to read the corresponding x values. So I didn't do my graph right. I just right now paid attention. This should have been a little bit like that, steeper. So let me just erase this part. This should be erased here. Okay. That's how this part is. So it says when x is -2, when y, this is your y value, your y value is -1, that's my y value. So you're going to put your pencil at -1y and trace the graph. The graph is right here, right? This is where the graph is, and the x value for it is also 0. So that's one of the x's. One of the x's is 0. What others? Then also there is another one here, and that is -2. So that's another x. So -1 and 0. But they don't want you to put it like that. They want you to separate your x's with commas. And then another one is -1 and -1. And then another one of them is right here, which is +2. So these are the x's that give you -1. All these x's. 0, x, -2x gives you -1, +1 also gives you -1. This graph is supposed to go through this point, okay, like that. So that's how you write your answer. It says x is where f of x is -4. This is -4y, right? This is your y value. It says when y value is -4, where is the graph? Trace it. -4, this is where the graph is. And for this one, we have 1. And for this one, we have x that is -3. So separate your x's with a comma. So when y is -4, the graph is here, the corresponding x is -3. When y is -4, you have graph on this side. The corresponding x is +1. So these are the x's that give you y is -4. How many x-intercept do you have? X-intercept is where the graph touches or crosses the x-axis. So if I want to look where the graph is touching or crossing the x-axis, I have to go to the graph. I see that it's touching it at this point and it's crossing it at this point. So these are my x-intercepts. It says, I think the question says x-intercepts, and it gives you a menu, drop-down menu, how many you have, 0, 1, 2. So you have 2 x-intercepts, 2 x-intercepts. What are the x-intercepts? One of them is this one, where the graph touches. So x is -1, y is obviously 0. That's one of the properties of x-intercept. Your y value is always 0. This is your other x-intercept. Again, y is 0 and x is +3. So you have 2 x-intercepts. What is the y-intercept? Y-intercept is where the graph is going to cross the y-axis. So the graph right now is crossing the y-axis here, right, at this point. And that is x is 0, y is -1. So when you're looking for y-intercept, your x is 0. When you're looking for your x-intercept, your y is always 0. That's always the case. So this point is where the graph crosses the y-axis. X is 0, y is -1. It says, what is the domain? The domain of this graph, there's a solid point here. So it means before -3, we don't have any graph. Our graph starts with respect to x-axis from -3. This arrow means this goes on forever to infinity, So your domain starts from -3 to infinity. And the reason we put a bracket for -3 because we have a solid dot here. If this was a open circle like that, you would have made that a parenthesis. But that's not what we have. We have a solid point. What is the range? The range is where we have a graph with respect to our y-axis. With respect to our y-axis, the graph starts from -4 and goes all the way to 2. We don't have any graph above 2 on the y-axis. We don't have any graph before -4. So the graph is going to be bracket from a small, comma, big. At 2, we have a graph, a solid line. At -4, we have this graph and this graph here. So both get brackets. So that is your domain and range. Let's go over question number 2. Question number 2, we are going to graph this function. First, I'm going to do it here by hand, then I'm going to show you how you would do this in Alex. For x's that are less than 2, x's that are less than 2, these are x's that are less than 2 because that's 2 here. For that, including 2, we have this quadratic equation. We are going to use transformation to graph a quadratic equation. The graph of a quadratic equation with your knowledge of transformation is a parabola. Because of the negative is downward, and we have to shift it up 4 units. So you have a downward parabola maybe here, then you have to shift it 1, 2, 3, 4. That's where the graph is going to locate. That's your graph for -x to the power 2 plus 4. But you only have this graph for x's that are less than or equal to 2. So I cannot put this graph for all the x's, like for these x's, I cannot have this graph. I cannot have this graph for these x's because this graph keeps going and going, and I'm not supposed to have that graph for those x's. So I go to this point 2, this end point 2. I substitute it here for x. I get -2 squared plus 4. -4 plus 4 is 0. So when x is 2, this end point 2, this is my y, this is my y is equal to 0. When x is 2, corresponding y is 0. So that's this point. And since I'm supposed to have this graph for yellow x's, I have to erase the part that is for green x's. I have to go and erase this part. Let me clean it up. I can't have the other branch or the tail of the graph on this end. So I have to get rid of it. For the green x's, I'm supposed to have this other function. So I want to graph this linear equation. How do I graph that linear equation? Very easy. I say y is equal to 5x minus 10. Let me pick a number for x. One of the numbers you pick for x should be this one, 2, the endpoint. Substitute it for x and find the corresponding y. 5 times 2 is 10. 10 take away 10 is 0. So if x is 2, if you substitute 2 for x, you do the arithmetic, you get y is 0. So that's this point, which is, again, 2, 0. Although, do you see this is x has to be greater than 2? I'm not supposed to have a solid point, but that solid point is there for the above graph, for that parabolic equation, for this parabola that I have here. Oops. So this is the green graph. This is the yellow graph. So I want to graph this one. I write y is equal to 5x minus 10. One of the points should be this endpoint. Substitute it here, find the y, and plot it here. It lands on the same point, which was the part of that graph. So then pick one more point. Pick one more point from green area, like 3 per se. So pick 3 for x, substitute 3 for x. 5 times 3 is 15. 15 take away 10 is 5. So when x is 3, corresponding y is 5. So then x is 3, I go to y is 5. I connect these two, extend from both ends. Let me just get this correct. My point is off. That's it. Let me just get rid of these. So I connect these two. And that is my graph. So the yellow graph for yellow x's and the green graph for the green x's. So you have to pay attention to this part. Let me do, let me go to the computer. And show you how you would graph this on, let me stop share. Okay, we want to graph this one. We are going to have a parabola. But we want our parabola to be downward. So let me read the direction. Oh, it's not telling me how to graph them. So let me see. So place the vertex, it tells you what to do. You place your vertex. It's going to be here. And then it says place another point. One point is going to be -2 and 0. By setting negative x squared plus 4 equal to 0 and subtract 4 from both sides, you get negative x squared is equal to -4. Divide both sides by -1, you get x squared is 4. A square root both sides, you get x is +2 and -2. So that's one of your points. And then you have another point. Oh, it's not letting me. So let me erase it. Or ladder, let me just go here and undo everything. Okay, so let's try again. So I'm just going to go to +4. That's my vertex at 4. It says put one of your points. I think you should put your end point. So the end point is at 2 and 0. That's your point. Oops. So then I want to go use the scissor. And it says plot a point to edit. Enter a point where you would like to cut the graph. Click plot point to edit graph, then use the eraser as needed. I don't know if this is going to do it. I want to cut from 2 to 0. Maybe I should use eraser. Okay, that's the point. That's what I deleted. I want to have a solid dot here at this point. That's a solid, okay, for that graph. Now, I want to go graph this one, 5x minus 2. Do you remember it was a line? So I want to have a line, and one end is going to be here. And the other line was at 3 and 5, which is here. Again, I want to go and cut from 2, 0, 0. I want to and then I'm going to use the scissor. Oh no, I'm going to use the eraser and erase it. Let's see, this graph is correct, but I don't know if I did the steps correctly. Check. It took it. So that's how you graph it. So let me go back to my iPad to do the next problem. And I look. All right. Okay. So the next problem. Question number 3. We want to find G, compose G and N. So sort of grown of X. That means we want to substitute N in G. We want to change that X. That's what it wants you to do. It says go to function G, go to function G. This is function G. And change all the X's in G to N. That's what this asks you to do, sort of like that. So I want to change that X to N, but what is N? N is X minus 6. So since N is X minus 6, I put X minus 6 there. So I get 1 over, instead of G is 1 over X plus 10, but it says take N and put it in here. And N is X minus 6, so I have to change that X. That's the only X I have, to X minus 6. That's my new X. This X should be changed to X minus 6. Let's simplify this. I have X minus 6 plus 10. minus 6 plus 10 is 4. We get x plus 4. And that is our gun of x. It says find its domain. When you're finding the domain of these functions, you have to first take a look at the function that you fed it into, this n. You have to make sure, look at the domain of n of x first. We don't care about the domain of g. We care about the domain of n. N is a polynomial, so the domain of n is everything, all negative and positive numbers, real numbers. So that's the domain of n. But what about the final outcome? The final outcome is a rational function. You can obviously put everything in here because negative 4 will make this 0. So subtract 4 from both sides, you get x is negative 4. That's your bad point. You don't want to have a negative 4 here. So your domain is going to be negative infinity to all the way to negative 4. Exclude negative 4. Again, start from negative 4 to infinity. So since the domain for n, the starting function that we fed it to g of x, its domain was everything because we had a polynomial. But then when we fed it to this new function, the new function is a rational function and we can't have 0 in the denominator. So we set the denominator equal to 0 to find that bad point, which is negative 4. Then we say everything before negative 4 and everything after negative 4 is okay. So to write that, you start from negative infinity, you go to negative 4. You can't have negative 4, you put parentheses. Then you can pick up everything after negative 4 to infinity. So you always put parentheses for negative 4 because you don't want them. Question number 4, we are going to do all these things for this function. We want to find out whether the graph is upward or downward. That's really easy. So you look at the number next to your x to the power 2. This is your x to the power 2 term. The number next to it is a negative number. So therefore, that means your graph is downward. So you say the graph is downward because you have a negative 2. The graph of this function, which is a quadratic function, is going to be a parabola. Because your coefficient for x to the power 2 is negative, your parabola is going to be downward. Now the question is, if I had this xy plane, where would I put this downward graph? Do I put it here, here, here? Where do I put it? To find that out, we have to find this point, which is called the vertex. So that's what we do next. There is a formula to find a vertex. Remember, this point has an x value and a y value, or any of them, right? Any of these vertex, you need to know their x and y values. So in order for me to find the x value of the vertex, there is a formula. That formula says to find the vertex, you are going to use this formula minus b over 2a. So what is our a here? This is our a, negative 2. What is your b here? Your b is negative 8. So you are going to go to this equation, put negative because of that, 2 on the bottom, 2 times a. Your a is negative 2. Your b is negative 8. Negative, negative is positive. Positive times negative is negative. Positive over negative is negative. You get negative 2. So x gives you negative 2. What is the corresponding y? To find a corresponding y, all you have to do is, remember, for a vertex, you need to find the x and y of the vertex. All I did right now, I have the x value of the vertex. To find a corresponding y, I have to substitute it. Instead of f of x, I'm using a y notation. I have minus 2 times x to the power 2 minus 8 times x minus 8. That's my equation. I just want to change all the x's to negative 2 to find the y value of the vertex. Negative 2 to the power 2 is negative 2 times negative 2, which is positive 4. Negative 2 times 8, the 4 is negative 8. You see, I'm going slowly one step at a time. Multiply these two. 8 times negative 2 is negative 16, but I have a negative here, so I carried it. I multiplied these two, I got negative. Negative and negative turns that into a positive. Then I have a minus 8 and minus 8. That's minus 16. Both are negative. Let's add them. I get negative 8 and negative 8 is negative 16 plus 16 gives me 0. So that tells me that the x value of the vertex was negative 2 and the y value of the vertex is 0. I have to find my x-intercept. To find the x-intercept, you set your function equal to 0 and you solve for x. So we are going to change f of x to 0 to find the x-intercept. To find the x-intercept, you change y to 0, you solve this equation. To solve this equation, I see that every single term has a common factor 2. My leading term is negative, so I factor a negative 2 first. Negative 2 over negative 2 is 1. Negative 8 divided by negative 2 is positive 4. Negative 8 divided by negative 2 is positive 4. Or you can say that this is negative 2 times x to the power 2, negative 2 times 4x, and negative 2 times 4. Do you see they all have this common factor, negative 2? So I'm keeping it outside. Then I'm going to be left with x to the power 2, positive 4x, and positive 4. How do I factor that? I look for two numbers to multiply to give me 4, 2 times 2. And if I add them, I also get 4. 2 times 2 is 4. 2 plus 2 is 4. So the factors are positive 2 and positive 2. So I have 2 of them, right? So I write it like that. Or you can set it equal to 0 or set it equal to 0. Just solve one of them. So the x-intercept or x-intercept is negative 2 comma 0. Negative 2 comma 0. We have 2 with multiplicity of 2. With multiplicity of 2. To find your y-intercept, you are going to go back to this equation again. To find the y-intercept, you're going to put 0 for x's, right? You have x to the power 2 minus 8x minus 8. You're going to change these x's to 0. 0 times 8 is 0. 0 squared is 0 times 2 is 0. So you have a negative 0, negative 0, negative 8. So negative 0 is just 0. And then if you have a 0 with negative 8, that's all you get. That's the answer. X is 0, y is negative 8. To graph it, we are going to put our vertex, which was at x is negative 2, y is 0. And if you notice, is the same as our y-intercept. So this is our y-intercept and vertex, both. X-intercept, sorry. It is both x-intercept and vertex. And remember, it has a multiplicity of 2. That's why it touches the x-axis. The graph is downward. And the y-intercept is negative 8. So negative 2, negative 4, negative 6, negative 8. So that's my y-intercept. So that's negative 2, that's negative 8. I go this way. And I have to go with the same curve this way. So that's my parabola. It's a downward parabola. That is my y-intercept. This is my x-intercept and the vertex, both. And then we are going to look at the axis of symmetry. That's the axis of symmetry. It's a line. You get x is equal to -2. That's always the x value of the vertex. That's always the value of the vertex. That's your axis of symmetry. Since the graph is downward, this is the highest point of the graph, which not the x value, the y value here is 0. 0 is the height of the graph. The y value of the vertex is your maximum or minimum. In this case, is the maximum. So our maximum is 0. Our axis of symmetry is x is -2. And the domain is always everything because we have a quadratic equation. And the range is always something to the vertex or vertex to infinity. So the graph is going downward. This is -infinity on the y-axis, all the way to 0. The range is -infinity all the way to 0. And there is a graph on 0, so we put a bracket. For infinity, we always put parentheses. When you're writing your domain or range, always a small comma, big, because these are not your x, y. These are all your y values. These are all your x values. So I am going to question number 5. And for question 5, we have h of x equals to x to the power 4 plus 3x cubed minus 10x to the power 2. This is graph. First, we have to find the end behavior of this function. So you have a chart. We have x even, x odd, x negative even, x negative odd. If x is even, that's your graph end behavior. If you have a negative even, that's the behavior. If you have an x odd, positive odd, these are the behavior. And if you have x negative odd, it reflects, that's the behavior. So let me just change this one as well and do the same thing, behavior. So these are the 4 categories that you have. And the way the wording for these is you say, because the graph starts from top, ends on top, you say up to the left. So on the left, the graph is up and up to the right. That's the language they use. I like to say the graph starts on the top, ends up on the top. Up to the left and up to the right. So it's up and up because we have a positive x to the power 4, and that is our leading term. The leading term is the term with the highest exponent. You look at its coefficient is positive x to the 4, so that is what happens. And the next question they ask you about this function, they want you to find your y-intercept. So that's 1, part 2. What is the y-intercept? To find the y-intercept, remember, I told you change h of x to y and then substitute 0 for your x's. 0. 0 cubed is 0 times 3 is 0. Minus 10 times 0 is 0. You just get 0. So your y-intercept is 0. When you put 0 for x, you're getting 0 for y. So that's your y-intercept. Then it's going to ask you to find your x-intercepts. To find your x-intercept, you are going to x-intercept, or sometimes they say find the zeros. So part 3, x-intercept, or it says find the zeros. So I'm going to take my function. X-intercept means change y to 0 or h of x to 0, and then solve the equation. if I want to solve this equation, I need to factor the greatest common factor, which is x to the power 2, because this one is made out of x2, x2. This one is 3x2 and 1x. This one is 2x2. So as you see, they all have this x2 common factor. So I'm going to keep it out. I get the leftover x to the power 2 plus 3 and x minus 10. Next, I'm going to factor this quadratic. I look for two numbers to multiply to give me negative 10. To get negative 10, I can put positive 5 and negative 2. But then if I add these, would I get 3? And the answer is yes. So 5, positive 5, and negative 2 are the factors. You break x to the power 2 as x and x. You put positive 5 and negative 2 inside each parentheses. You factored the equation. Now finding the x-intercepts are very easy. Opposite of positive 5 is negative 5. Opposite of negative 2 is positive 2. And then when you have x to the power 2, that gives you 0. It has a multiplicity of 2. That means at 0, the graph is going to touch the x-axis. When the multiplicity is even, the graph touches the x-axis. When the multiplicity of these parentheses is odd, like 1 is odd, the graph is going to cross the x-axis. So let's put what we have. Let me just draw a better xy axis. I have negative 5. I have a positive 2. I have a 0. My graph starts from the top, goes crosses negative 5 because this one has an odd multiplicity. It gets crossed. I have a 0 as an x-intercept. It gets touched. And then I have a positive 2x intercept with odd multiplicity, so I have to go cross it. And that's just a rough graph. So I am going to tell you how you would graph this in Alex. You have to have at least 5 points for these. So one of your points is obviously negative 5, 0. This one, right? That's your x-intercept. When y is 0, you get negative 5. So negative 5, comma 0. One of your points is this one, 2, comma 0. One of your points is your xy intercept, which is 0, 0. So you have to enter them. But that's not enough. You need also 2 more points. How about if you substitute 1 and negative 1 into your equation? So you had h of x is equal to x to the power 4 plus 3x to the power 3 minus 10x to the power 2. Substitute negative 1 to see what y you get. So put negative 1 for your x's. Let me just go do that. I'm going to change my x's to negative 1. And since x is negative 1 and has to be multiplied and raised, you should put it inside the parentheses. And negative 1 is an easy number to do arithmetic with. So negative 1 to the power 4 means negative 1 times negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is 1. Negative 1 times negative 1 is 1. 1 times 1 is 1. So don't make a mistake and write it as negative 4 or 4 or something like that. Do the arithmetic. Plus, let's find negative 1 to the power 3. Negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is 1. 1 times negative 1 is negative 1. So you get 3 times negative 1. Let's raise negative 1 to the power 2 as well. Negative 1 times negative 1 is positive 1. So this is just going to be positive 1. Then I'm going to multiply these two and multiply these two. 3 times negative 1 is negative 3. 10 times 1 is 10. Positive, negative, you can't do that. You have to decide. Positive, negative turns out to a subtraction. You have two negative numbers, add them. You get negative 13. And then 1 minus 13 is negative 12. So one of your points is going to be that you enter, besides those, x is negative 1, y is negative 12. Do you see I was here? I should have gone further down and go up. So it improves your graph. Let's pick positive. I'm sorry, not this side. I made a mistake. This should be, that's for positive 1. This should have been here, like that, for instance. So anyways, let's go back and do another point. This time I am going to substitute positive 1 for x. So this is positive 1. This is positive 1. And this is positive 1. So let's see what we get. Right? We are substituting positive 1 for x and see what we get. So 1 to the power 4 is 1 times 1 times 1 times 1, which is 1. 1 to the power 3 is 1 times 1 times 1 is 1. Oops, I lost everything probably. But good thing I remember most of it. So that entire graph is gone, but remember, we know, let me just get a new page, because the page, when there's too much going on, I lose the data, but that's okay, because I remember most of the points. One of the point was negative 1 gave me negative 12. And negative 5 was 0, positive 2 gave us 0, 0 gave us 0, and then we wanted to find out what we get if we substitute 1 for x. So if I put 1 here, I get 1 to the power 4 is 1, 1 to the power 3 was 1, 1 to the power 2 was 1, 3 times 1 is 3, 10 times 1 is 10. I have two positive numbers, let me add them. I have a subtraction, 10 take away 4 is 6, but I get negative 6. So when x is 1, you get negative 6. So what you do is you prepare these 5 points, and you are going to enter them into ALEX. So you type 1, negative 6. And what happens is you're going to see this point. Suppose that's negative 6, and suppose this is negative 12. Then you put negative 1 and negative 12. So when you put negative 1, type in negative 1, negative 12, this point will appear. Then you put negative 5 and comma 0. So negative 5, comma 0, that point appears. You put positive 2 and 0. If you put positive 2 and 0, this point will appear. Then you put 0, 0, this point will appear. And then you already have told the graph starts on the top, ends on the top. So you will have and then you click on this graph. There's going to be a curve. You click on that icon, and your graph is going to appear. I'm going to stop here and have another video.